Hi everyone, my name is Louisa, and today I'll be presenting my research poster investigating the antimicrobial and antioxidant effects of organic and non-organic sage polysaccharides. So medicinal plants have been used for a number of years. They're accessible, abundant, and have various different health benefits depending on the plant. Sage is a common kitchen herb, but it holds many health benefits, such as curing throat infection, and is often consumed as a herbal tea for this purpose. It was discovered in previous studies that medicinal properties in plants was from polysaccharides, a large structure composed of smaller monosaccharides. It was questioned whether this structure was affected based on the growth condition of the plants. Therefore, this study aimed to compare organic and non-organic sage polysaccharides for their yield and benefits. Additionally, the research project explores the question if monosaccharides provide similar results or if the composition of the polysaccharide structure is related to its medicinal properties. The experiment began by extracting the polysaccharides from organic and non-organic sage powder. The extraction method used was hot water and alcohol precipitation. Briefly, the sage powder was first mixed with water and heated to 90 degrees Celsius for 4 hours. The infusion was then mixed with ethanol to precipitate the crude polysaccharides, which were then purified by using anion exchange low-pressure chromatography. The polysaccharides were then quantified by employing the phenol-sulfuric acid method, which was a calorific reaction commonly used to quantify carbohydrates. A dextrose standard was used for this test to compare samples. The bacterial tests were done with two different strains of bacteria, S. aureus and E. coli. The first test used was the bacterial zone of inhibition test, and the positive control used was ampicillin and 400 micrograms per ml, and negative control was 1x ppb. Plates were incubated at 37 degrees Celsius for 24 hours to observe the zone of inhibition. For the minimum inhibitory concentration tests, positive control of ampicillin at starting concentration of 50 micrograms per ml, D-galacturonic acid at 30 milligrams per ml, and neat samples were diluted twofold across the plates. After bacteria was added to the wells, the plates were incubated and observed for the wells without bacterial growth. The FC assay and DPPH assay were used as antioxidant tests. The standard used was gallic acid at a range of 5 to 200 micrograms per ml, and each sample was run at a neat and a 1 to 10 dilution. The relative gallic acid equivalent concentration was then calculated by interpolating the standard curve data. The results of this experiment were unclear for yield, as the phenol-sulfuric assay did not produce a color change in either standards or samples. For bacterial tests, growth inhibition was not certain. As you can see from the zone of inhibition tests here, S. aureus did not completely cover the agar plate, so while it seems like there is some inhibition, it did not produce a clearly visible disc, such as the E. coli positive controls here. In the MIC test, growth showed in all wells except positive control and D-galacturonic acid, which inhibited growth at a concentration of 15 mg per ml for S. aureus and 7.5 mg per ml in E. coli. In the antioxidant tests, non-organic crude polysaccharides showed a significantly higher amount of phenolic compound and scavenging activity than the organic crude sample. Upon testing the sage infusion alone, the organic sage tea sample demonstrated significantly higher antioxidant properties than the non-organic sage tea over here. While the results of this experiment did not correspond with previous literature, it was concluded that there may be possible benefits in polysaccharides and that non-organic sage has either more polysaccharides or better properties found in these polysaccharides. Furthermore, we can also conclude that sage infusions are most antioxidant when using organic sage than non-organic sage. For future directions, extraction efficiency of polysaccharides could be compared to the stage infusions to see if similar results come up. More research could be done on cells using these compounds too. A major issue with this research was that none of the polysaccharides were able to be quantified using the phenol sulfuric assay, so better polysaccharide quantification, purification, and extraction methods could also be tried in the future. These are my references over here, and I would like to thank all of Holland College staff and instructors for helping me conduct this research. Thank you for listening to this presentation.